Hey guys, so hopefully this will be a little bit helpful in doing your homework for this week. I'm thinking about extending the due date for the homework to Monday, just so you guys don't have to cram it in all over the weekend, because that's not really super fun. So by the time I finish this recording, I will have made up a decision on that. However, here's some Python help for your visualizations for this week. So first, in your code, you're going to want to import the necessary libraries. Like I told you guys before, I like to use Atom as a text editor. Up here, you can see if you save it as a .py file, your program will color coordinate, kind of like if you had a text editor for another language that gives you the different colors for different things. So it's a little bit nicer that way, just to kind of see your code. I really like using Atom personally, but you can use another text editor if you so choose. Then what you're going to want to do with your program here is you're going to want to save it somewhere. It doesn't matter where you save it wherever. However, the file that you're using, your dataset file, has to be saved in the same spot, dataset file, same spot as your program file, in order for it to run in your command prompt. So that's one of the things that you guys might not have known before, which could cause some problems. So as you can see, the first step is going to be importing your necessary libraries. Depending on what visualization you're using, it could use a different set of libraries. Some, only use pandas and matplotlib. Some will use Seaborn. Some will use whatever. Just make sure, look in the book at the examples and make sure you're importing the right libraries. Otherwise, you could import all of the libraries every time you do it, just kind of as a fail safe. But otherwise, just double check that. So if it's not working when you import those, you might have to install the necessary libraries, which also is a little confusing. However, you do this in your command prompt with your pip install command. So I'm going to open my command prompt. This is kind of just the generic thing that pops up. If you do pip install and then we'll say pandas, so mine is already satisfied. It means I already have it installed. This could be another problem you guys might have been running into, why you were getting errors if you didn't have the libraries installed with it. So go ahead and try that. If you guys were having troubles getting the visualizations up, install each of them. There's a whole mess of necessary libraries here. You should be able to just use these module names, but otherwise you can always Google it and see what you have to pip install for the specific libraries. Here it'll kind of show you what these are used for. We'll use the scikit-learn later in the book when we hit machine learning. But otherwise, Seaborn's really popular, Panda's really popular, Matplotlib, just to kind of get the necessary visualizations that you want. So the next step in your code is going to be loading your data set. We're working with mainly CSV files. If you don't have a CSV file data set that you're working with, you can either try to upload it as whatever file extension it is, such as an XLS file or whatever it comes in, but you can also just resave the file as a CSV, and it should follow this same procedure and it should work just fine. So as you can see, that's the next step here. We have importing and then loading our data set. Okay. Now here, with the DF, DZDL, these are just data frames. Essentially, I'm reading in my CSV file, and then here I'm just picking smaller chunks of my data set to use. You can pick kind of any data frame you want if you're choosing to work with the largest 100 records, the smallest 100 records based on a certain category, or kind of anything like that. You can kind of shrink your data set size so that you're not working with your entire data set. So then we're going to move on to attributes, and this would be kind of how to do question 1 of your week 1 homework. Essentially, you can program it where it'll spit out this information using these attributes. So for example, D types, it'll spit out what data type is in the data set. So it would give you a printout of all of your column names, your column headers, and then what kind of data type it is. So whether that's a float, an int, a boolean, etc. This is one way to do it. This is another way to do it here. I was having some issues earlier with it, so I'm looking into it, but give it a try. If it works for you guys, that'd be awesome. But yeah, it just spits out the information for you instead of having to go into the dataset CSV file and look at the information. It'll print it out. So that's a way to visualize that question. And then here's another just copycat slide of that one. So then data frame methods. Methods kind of gives you some statistical information about your records, but also you can choose your first 5 records or your last 5 records. So kind of similarly to data framing with your top 100 records based on voting rating or whatever, but this one won't pick based on a column. It'll just pick in order of the records that are in the file. And then you can also pick specific columns that you want information from. So if you only want specific information from 2 of your 12 columns, this would be a way to code it. The Titanic is the data set, and then these are your column names. So pick column headers from your other thing. You can even print it out. If you put print and then Titanic in your column headers, it'll just print out the column headers, or it'll print out the first 5 records. And that's kind of just a neat way to see your first 5 records or your last 5 records, or other data methods here. You can get summary statistics, your min and max values. You can get a random sample row. So that's also useful just to further understand your data set information. So now we're going to get into the visualizations. And the first one is a bar plot. Now this code comes straight from the book. You can copy it almost verbatim for your own data set and just change what data set you're loading in. Here is where it loads in the Titanic data set. That's just a Python data set that's kind of built into their libraries that it knows how to run. So here's where you're loading in the data set, and then here is where you are telling your visualization what data set to use. So this one's using Seaborn and SNS and taking in the Titanic data set. If you were to load your data set and then title it whatever, this would give you a bar plot for your data information. But you do have to pick, like here, your X value, your class, that's a column, that's a header that's showing you something. So I urge you to go back into chapter 1.5 in the book. It gives you some examples. Kind of look at the layout of a bar plot. Because sometimes, if it's a count that it's giving you, pick something that's countable to visualize with a bar plot. But again, this can be done, just import your own data set into it and kind of putz with it and see how it works. Similarly with pie charts, you can follow this code verbatim, especially for right now. It's easier to learn that way if you just take that code and work with it. But you can definitely putz with it, and I'll show you in a second how to do kind of how you can putz with it. But again, you load your data set here, and then for pie charts, you have to break it out. So you're basically telling the pie chart, I have 100% of this, and this is what I'm breaking it down into. So for this one, it's breaking the Titanic data set into first, second, and third class passengers. And then this is saying, like, my pie chart is made up of A, B, and C sizes. A, B, and C is here, your count. So anything that you put in here is going to make this up. Now, an alternate example for this is using the books of the Bible. This is showing the percentage of verses in the Bible that are gospel verses and then splitting it up by gospel. So here you can see each piece is broken up by gospel and it's counting the number of verses. So in this particular data set there is a column called verse, number or whatever, and it will count it up. Now here E is going to be my total. So as you can see, I have A, B, C, D, E. Well, E, this is the total number of verses in the Bible. So for me, I had to subtract this. I didn't know what the number was. So instead of trying to figure that out, you just subtract what these are, and then that'll give you the rest of your pie space here. Now to kind of putz with it, you can change a lot of things, one of which is being the color. When this originally printed out, it was not a pretty color. It was like a muddy, like this color here, the whole thing was that, and it wasn't visually appealing to me. So you can kind of, Google it, look into it, see, how you can change the color, how you can change this, that, and the other thing. You can create, your labels. You can have your percentages on the outside, your percentages on the inside. You can have a count instead of a percentage shown. So there's just definitely a lot of different ways you can manipulate once you've gotten the basic chart down. The next plot is a scatter plot. Again, straight from the book, you can copy and paste it. This one uses the IRIS dataset instead of the Titanic dataset. Again, it's a built-in dataset. The IRIS one is really popular. You may have used it before, you may have heard of it before. It's basically taking petal color length width of different iris flowers. It's a really big one with machine learning, which we will look into later in the course. But again, if you follow it, if you put in your data set, so here you're loading your data set as DF. Here you're picking the column headers in DF. So here you'd have to pick your own column headers. Scatter plots work really well when you have a lot of information. Not so well when you don't have a lot of information. There are probably other visualizations you could use for that, but definitely try it, test it out, see how it goes. And then different forms of scatter plots. So this strip plot is the one that plots it just straight up and down in almost a line, but it's dots. Again, you can kind of mess with it once you got the regular original down. And these slides are posted online, so if I'm going too fast, you can go in and kind of relook at it later. A swarm plot is another form of scatter plot. Again, just test it out with the data set, put in your own data set, pick random things. If it doesn't turn out right, which I'll show you, I have an example later that something just didn't turn out right, just put in a different piece of the data set and it'll look totally different. And then a line chart. So again, you could follow this pretty much to a T, put in your own data set, pick your own headers here, you figure out what you want, and just kind of test it out. Once you get the hang of it, kind of tweaking things really isn't that difficult, which is kind of nice for this. So this would be chapter 2 visualizations now, a box plot. So this one I have an example later where it really didn't turn out very well, but this is example code. This one's not straight from the book. This is something I did, and I'll show you when I run it in a second. But I did work from the book to plot it. I have my own data. My DZ data that's what I had defined as above. This is how you show your plot. If you program it for plot show, this is when you run it, it'll actually pop up on your screen. But also plot save fig. This will save your thing as an image to your computer that you can go in and have later. But yeah, so this code spits this puppy out here. That's pretty much all I got for box plots. Histograms similarly. Again, a really simple set of code for this visualization. It came pretty much straight from the book, but this is my own code. The big thing for histograms is this bin size. The number of bins gives you essentially 1, 2, 3, 4, 5, 6, 7, your number of bars in your histogram. Now this one, it's incredible how much, you know, a 5 or a 9 in this spot can change how this looks drastically. So that's kind of a fun one just to mess around with, just to see how it looks. The big thing is when you are drawing a line from these points to one another, kind of creating a curve over it, you want the least amount of white space. So here, this 7 might not be the most appropriate because it's got a huge white space over here. So that's where messing with the bins, number of bins, is really big and kind of creating the best optimized visualization for histograms. For violin plots, again, super simple code. This is it. Once I imported my libraries and loaded my data set, I have my data set here. This is all you need for a violin plot. Now there are different kinds of violin plots. They have the ones that kind of stack next to each other, or you can do two in one visualization. It's definitely something to look at. It can come in handy, but they are a bit more complicated to use. A lot of people aren't used to seeing them. They aren't used to understanding what it is. Remember, violin plots are kind of a mix of a box plot and a histogram. So it shows all the statistical data with a frequency element, but they're not used very often, so people don't really know how to read them. So now I'm going to show you how to run the code. So here I have my program written out. This is for the box plot, histogram, and violin plot. So here we have imported libraries, loaded data set. I have box plot code, histogram code, violin plot code. It's saved as program 9. So here now I am going to go into my file, and here's where my program 9 is saved. I'm just going to grab this path. I'm going to copy it here. This is the path that you're going to need. So in my command prompt, I am just going to cd and paste my path there, and that has loaded my path. So now I'm in that file, and I'm ready to go. Now to run Python code, you need to type out the word Python. That's your first piece. Then you're going to type out your program name, and you need this .py. So without the Python, it's not going to work. Without this .py, it's not going to work. However, when you run it, it'll take a second, but because I have those plot shows in my code, hopefully it'll work. It worked yesterday when I made the video. There it is. Okay, so if you don't write plot show, it's not going to show you. It'll just automatically save them. However, this is the first box plot that we have. So now if you exit out of this, once you exit out, it'll pop up with the next piece. Theoretically. There we go. So this is the one I was telling you about. This is supposed to be a box plot. This is my failed box plot. But again, you don't know that it's going to fail until you try running it. So, you know, if you get something that looks like this, adamant attempt, it is a box plot technically, but something didn't quite work in the pieces of the data set that you were trying to compare or trying to visualize. So that's when you have to go back and kind of tweak what you're looking at. If you have too big of a data set, sometimes it'll do this. Let's say you have a data set with a lot of outliers. That's essentially what this is telling you, is that these are all outliers, your boxes over here. So, you know, maybe try to pick a data frame of it, pick a smaller subset of your data set to work with. But I mean, it happens. You find something and it just doesn't work. So this is the histogram here that pops up next, and then the violin plot pops up after that. So once you're done, it's done. It'll give you a new command line. You can run it again. You can run a different program. However, the pictures, if you have in your code your plot save fig, it will be saved somewhere on your computer. Search, you know, look for whatever you named it and search it in your thing, in your file explorer, or if you know where it's gonna save it, go straight to it. If you don't save it, that's fine. Just get a screen capture of it while you're running it. Make sure you do the plot show and then take a screenshot of the plot show if you can. and then upload that into a document. You can compile one document for it. It's not a big deal, just like a Word document, and then just paste your screenshots. But then this code, your program code, upload that file too. You can upload it as a text file. You can upload it as a Python file. But that's the big thing. If you don't get it working, like if you have all this code, something's not working, you're stressing out, that's fine. But upload it anyway. Upload your file, submit your file. Don't just switch to another language. I commend you for trying, your week 1 in a different language, but this one's about Python. So even if you can't get it working, submit your Python program file. I want to see it. I want to see how far you got. I want to see, that you tried. If you get half of them working, that's fine too. You can, I always had I like working with a combined file for homework assignments, but when I'm testing each question, I'll have like a test file so that if one piece of my homework file isn't working, it's not going to mess up the other pieces. So let's say you get question 1, and you're struggling with it, and your program errors out on question 1, so you can't test questions 2 and 3 if they're in the same file. We'll just have a side program set up that you can test it and be like, hey, this works, and then submit either all your files or submit your combined file. I'll go through it and run it and see how it does. But definitely include both your screen captures or your images and your program files, because I really want to see how you guys do with this. I will try to update the Dropbox date for both of the homework assignments, the redo homework 1 and the homework 3, for Monday. I'll switch it to Monday. If I can't switch it to Monday, you have my word right now that it is switched to Monday at 11:59 p.m. So even if it's a late submission on Blackboard, I'll look at the date and time that you guys submit it and make sure that it's not considered late if you guys turn it in Monday before 11:59 p.m. So if you guys have any questions, let me know. You can email me, Slack message me. Try to keep your notifications on for the Slack channel. I am getting like 0 responses, and it's a little frustrating. I don't want to have to email you guys every time I need a response. But it's really handy if there's something quick I have to throw out at you guys. Or if you have a question too, I have Slack open almost all the time. So it's a really quick way to get a response. Otherwise, if you guys need more in-depth help that's going to take more than an email or a question, let me know. We can set up a Zoom meeting. I'm fine with that if you guys need more of like a face-to-face chat type thing. I don't know if you guys have used Zoom before, but it's a really easy kind of just video conference call. And we can work with that too. So again, let me know if you have any questions. The homework due date for week 1 redo and week 3 will be Monday 11:59 p.m. Your exam 1 will be uploaded sometime this weekend, and it will be due by Wednesday 11:59 p.m. Everything else is keeping. Is there anything else? I don't think there's anything else this week. But if there is anything else, the reading assignment for chapter 3, that'll still be due Sunday night. So yeah, if you have any questions, let me know. Good luck on your homework, and I'm excited to see how you guys do this week.